Now the question asks us to find the minimizers and maximizers of the following function. Okay, we know that if we want to find those minimizers, maximizers, we need to find the first order necessary condition and see which point satisfies that. And from there, we can further check if any of those satisfies the second order necessary condition or second order sufficient condition. So let's do the first step, check the first order necessary condition. So that from that, we need to calculate the gradient of this f, and that is there are the two partial derivatives, so the gradient is just this. Okay, because this problem is unconstrained, so the first order necessary condition just becomes the gradient of f at that point, at a given point is 0. So if we want this to be 0, we essentially just need to set both of this to 0 and solve for x1, x2. Okay, and once we solve them, we'll be able to check the Hessian at there. So let's see what the Hessian in this case. The Hessian is just to take the second order derivatives, and this is the df dx1 square, and also df dx1 dx2, which is the same as dx2 at dx1, which is equal to 0, and also df dx2 square is the second order derivative of f with respect to x2, that is 2x2. Okay, and the Hessian matrix is just that. So once we get the critical point, we can check the Hessian there. Okay, the gradient of f equals 0, it just gives us this, and as you can see that there will be 4 possible values, or 4 possible points. The x1 is a positive plus minus 2, and x2 is plus minus 4. So these are the 4 possible combinations of them. So these are the points which satisfies the first order necessary condition. We need to further check their Hessian. So it's easy to check their Hessian, just plug in the value, just plug in those points into that, and you get the corresponding Hessian here. And similarly, you get the Hessian for each of these 4 points. And you can see that this Hessian matrix is positive definite. So that means this point here is a strict local minimizer. Okay, and also for this point, it has a negative definite matrix, Hessian matrix. That means that point is a strict local maximizer. And these two matrices are not positive definite or positive negative definite. So these 2 points are just a set of points. Okay, so now we found this point that is a local minimizer, and this point is local maximizer. But there are no constraints, and there are no any other local minimum or local maximums. So this is actually the global mean, and this is actually a global maximizer.